Here we're going to use the derivative to analyze change in cost, revenue, and profit functions since the derivative measures change. One of the first formulas I'm going to give you, though, is the formula for actual cost. And this is used to calculate the amount of money it takes to acquire or produce a specific asset or product. So if you want to figure out the actual cost in producing the nth unit, so we want the actual cost for the nth unit, what we would do is we plug in the total cost for all n units minus the total cost for n minus 1. That is, if you want to find the total, or the actual cost rather, the actual cost for the 100th unit, you would plug in C of 100 minus C of 99. You take the total cost for all 100 minus the total cost for 99, and it'll tell you that actual cost for one more unit, that 100th unit. Another thing we want to know is about marginal analysis. Marginal analysis is the study of the rate of change of economic quantities. Marginal cost is the actual cost incurred in producing an additional unit of commodity. So this marginal will approximate actual. So we have a formula for actual cost, and that's kind of the long way of doing things. We're going to use marginal cost because it's approximate to the actual cost. They're approximately the same thing. The marginal will estimate the actual cost. So, since the marginal is the study of rate of change, it is the derivative of the total cost function. So, when you're asked for marginal cost, what you're always going to do is just take the derivative. If I give you revenue and ask you for marginal revenue, you just need to know that marginal means take the derivative. And then we'll plug into that instead of having to plug into this longer and more time-consuming actual cost formula. We want to remember marginal, approximate, actual. So let's use that in this first problem here. We have the cost of producing X USB flash drives is given by this total cost function C of X. So capital C always stands for total cost. And it's 3,000 plus 4x minus 0.003x squared. And this is approximating for between 0 and 5,000 USBs. So they're only capable of producing between 0 at the least or 5,000 at the most USBs. But we don't really do much with that quite yet. We'll see that more in section 4.4. For right now, we're just going to use that total cost function to find the actual cost incurred in producing the 1701 USB. So 17 first. So to find the actual cost for just the 1701 USB, we're going to plug in C of 1701 minus C of 1700. Just like we talked about above, you do C of n, the number you're trying to find the actual cost of, minus C of n minus 1. So that's where I'm getting these numbers here. So I plugged into this cost function up here. When I plugged in 1701, the total cost that I got out for all 1701, it's going to cost $8,935.98 to produce all 17,001 of those. Minus when you plug in 1,700 to the total cost function, you get 8,933. So the difference between those two, subtracting them, is $2.98. So what that means is since the total cost for all 1701 is this much here minus the total cost for the 1700, the difference between them is $2.98. That's the additional cost, the additional actual cost for the 1701 USB. It will cost them $2.98. So if they're selling these things for $20, then they definitely should produce 1701. They should take an extra USB and make it. But if they're selling these for $3, then maybe they don't want to bump up their production level to 1701 because the actual cost for that one is $2.98. Let's compare that to the marginal cost when X is 1700 and see if our answer makes sense. So we want to remember that marginal is supposed to approximate the actual cost. So we're going to take the derivative here to find marginal cost. Marginal just means take the derivative. So if I take the derivative of 3,000, that's just 0, since it's a constant. Derivative of 4x is 4. And then I have minus, I'm going to bring down the 2 times 3 is minus 0.0006. And then I have x to the first is my new power. So plugging into that marginal cost, I'm going to plug in C prime of 1,700. And when I do that, I get 2.98. I want to see, does this make sense? Well, marginal analysis is supposed to approximate the actual cost in producing an additional unit of commodity. So plugging in 1,700 is going to approximate 1,701, that actual cost. So let's just write that down. This makes sense. Our answer makes sense. This makes sense because C prime of 1,700 approximates the actual cost for just the 1,701 USB. And we got pretty close. We actually got the same value. So we plugged in the actual cost for C of 1,701. It took a little bit longer because I had to plug into this long function, but I did it, and I got it that the actual cost is $2.98. My shortcut way would be just take the derivative, take the marginal cost, plug in C prime of 1,700, and that'll approximate the actual cost for the next unit. So that worked. This says the approximate actual cost. How I would interpret my answer in general is the approximate actual cost of the 1,701 USB is $2.98. This is the general interpretation that I would be looking for on an exam of what C prime of 1,700 means. Last piece here, find the average cost. So I'm going to be able to find average cost. We have a formula for actual cost, and we want to be able to find average cost, a different formula, and the marginal average cost, which of course is just going to mean take the derivative. I'm going to label each function. So average cost is a new formula. Average in math, we always put a bar over it to symbolize average. So average cost would be C bar. And we're going to find the average by taking the total cost and dividing it by the number of numbers. Same way you've been finding averages your whole life. Total divided by the number of numbers. So C of x is the total cost, and x is the number of numbers. So if we find the average cost for this function, we're going to do C bar of x. And we're going to take each term, and we're going to divide it by x. So 3,000 over x, plus I have 4x over x. And I have minus 0.0003 x squared over x. So then I could simplify this just because I'm going to be taking the derivative of it, because I'm going to find marginal average cost. Marginal always means take the derivative. So I'm going to rewrite this as 3,000, and x is to a negative 1 if it's in the denominator. 4x over x, those x's cancel out, and I just have 4. And I have minus 0.0003x. So there's my average cost function. I found that. And the next thing says find the marginal average cost. Marginal means take the derivative. So I'm going to say C bar prime. And my derivative is negative 3,000 x to the negative 2 minus 0.0003. And we're done.